Welcome to the Infrastructure 2020 BIM Forum. My name's Theo Agelopouls, and I lead the strategy and marketing team at Autodesk. Today we're going to talk about the future of infrastructure. No other company can provide the critical insights across all industries that Autodesk can. We service the media and entertainment, manufacturing, and AEC industry. This gives us the ability to bring best practices from all industries in order to benefit each other industry. Let's begin by defining what infrastructure means. Infrastructure is all physical systems that a community or country needs in order to operate. If you look at the global construction output in 2019, what you'll clearly see is that transportation is one of the fastest and largest growing industries. We sit at the intersection of multiple global trends that are driving big opportunities for Autodesk and for you. These trends are accelerating urbanization, aging assets, climate change, and finally, BIM mandates. So let's talk about each one individually. More and more people are moving to cities. We know we need to build more buildings, but we also need to build more infrastructure. We need to build enough roads, highways, and rail to circle the earth 30 times. And we need to build 20,000 more bridges each and every year. And that's just simply what we can see above ground. Below ground, there is a need to build 2,600 kilometers of new utilities every single day. That's the distance between London and Moscow. Thanks to all this demand, there is a $15 trillion pipeline of new projects on the horizon. Some cities need to build more and some need to improve, maintain and protect the existing built environment against natural disasters. The World Economic Forum forecasts that rising risks in the next decade around climate change will have a huge impact on the world. We're also seeing continued momentum around BIM initiatives around the world. You can see above the line, this is where we currently are seeing governments putting BIM mandates or BIM policies in place that impact the supply chain. Just this year, we saw Germany drive one of the largest BIM mandates around transportation. And at the bottom, you can see a lot of the many other countries that are upcoming with BIM mandates. But let's not forget the $1 trillion infrastructure gap. What that means is that we are spending $1 trillion per year less than we need to build new and maintain existing infrastructure. Boston Consulting Group did a study a couple of years ago that suggested if you completely digitize the engineering and construction supply chain, you would save $1.2 trillion on an annual basis. This is one of the main drivers that we've seen in the last decade that has really transformed the way that infrastructure projects are being planned, designed, built, and ultimately operated. What's really interesting is that if you compare the AEC industry against other industries, especially manufacturing, you can see that over the last 20 years, the construction industry hasn't grown in output productivity versus the manufacturing industry. And what's the biggest difference? Well, the biggest difference is that the manufacturing industry has embraced digitization, and the investment in technology is substantially higher in manufacturing than it is in construction. And that's one of the key differences that we see that's also driving the digitization of construction. So when you think about the increased demand, the limited natural resources, the higher quality and more resilient infrastructure that we need, it all drives towards the fact that we need to deliver projects that have better outcomes. So let me walk you through the digital journey as Autodesk sees it. When we talk about the digital journey, we really talk about it in 4 different phases. The first phase is CAD. CAD's been around for over 35, 36 years. And obviously Autodesk was one of the pioneers in the early days of moving from drawing boards to digital drawing boards with AutoCAD. The next phase really started about 15 to 20 years ago. And that was really the invention of BIM, or Building Information Modeling. And where we are currently today is really transforming BIM plus the power of the cloud, and we're calling it Connected BIM. And what lives beyond Connected BIM is really what we're calling the future of design. And I'll talk a little bit about each of these 4 phases. Building information modeling itself has transformed. When building information modeling first started, it really started as the word building being a noun, a physical building. And it was about modeling a building in 3D and then producing documents. And it really started with architecture and then eventually moved over to structure and MEP. The term building information modeling has transformed in the last 15 years to mean better information management. The word building no longer is a noun. It's a verb. It's an action word. It means that we are building a process that allows the seamless movement of information through planning, designing, building, and operating. And I would say over the last 15 years, we've really been focused on what we're calling the digital engineering part of BIM. And what you see currently happening, and as I mentioned earlier, where the biggest productivity gains can come, is really in digitizing construction. And that's one of the main reasons Autodesk made a $1 billion investment in acquiring companies like PlanGrid, Building Connected, and Assemble. And we're also investing in the future around digital operations with things like digital twins. So as I mentioned earlier, BIM, or Building Information Modeling, is really about a process change from drawings to models. We're no longer starting with a 2D representation of a project and then generating a 3D model, but we're really starting with a 3D model, a parametric 3D model with information, and then using that as the derivative to produce other things like drawings and many other valuable assets. Those customers that have made the switch from CAD to BIM have definitely seen productivity gains. And this is just a sampling of the McGraw-Hill report that happened several years ago that tried to quantify the biggest values in moving to BIM. And as you can see, some of the key and not only values are better understanding, optimized design, improved schedule, fewer errors, and greater cost predictability. These are the values that customers are getting today. We surveyed several customers ourselves, and what we found is those customers that actually used CAD generated in the order of 18% change orders. When they moved to BIM for a single discipline, that 18% went down to 11%. But when they really transformed their process into a multidiscipline BIM process, they were able to reduce change orders down to under 3%. So we know there's value there, and customers are seeing it that have made that transformation. Here's a real example from Denver International Airport, which obviously is where I'm from. Denver International Airport was one of the early pioneers of adopting BIM on the hotel expansion at the airport and the transit station. By adopting BIM, they were able to reduce their change orders by 40%. They were able to save 8,000 hours in simple coordination. And finally, they were able to finish 3 months ahead of schedule. And they attribute this all to the fact that they adopted building information modeling. This is one of my favorite BIM projects from Norway. It's called the Varma 12 project, where they're building a 12th new power generator on a hydroelectric power dam. What's amazing about this project is that 12th generator generates as much electricity as the previous 11 that were built in the early 1900s. But Norconsult really wanted to transform the way they were going to design and deliver this project. So this is a great example where Norconsult used many of the tools inside of the AEC collection, everything from Civil 3D, Revit, Navisworks, and 3D Studio Max, in order to be able to deliver this project in a transformational and a digital way. But the ultimate measure of success was the fact that Norconsult was able to deliver this project with a 90% reduction in change orders. We continue to heavily invest in our design authoring tools. What you're seeing is our effort to transform the way we design bridges. So we're now using Civil 3D alignments for bridge geometry in InfraWorks. InfraWorks allows us to do intuitive optioneering, and then from there we have the ability to publish that bridge model into Revit. We can then revise the bridge model, update the Revit model, and then also update the InfraWorks model, and then finally we have the ability to push that model into Civil 3D for final drawing production. We are connecting our own offerings together in a way that's unparalleled by anyone else in the industry. We're creating the seamless flow of information from conceptual design to detailed design to drawing production to bring a true BIM process to. We're also making significant investments in optimizing our rail and track workflows. One of the unique advantages that Autodesk has in the rail and track industry is that when you think about a rail project, there's a lot of vertical structures and a lot of vertical assets like rail stations where our customers are using Revit, which is the leader in vertical BIM, but they're also then using our horizontal design tools like Civil 3D and InfraWorks to do horizontal design. Here's an example where we're using scan to BIM and point clouds to create geometry. From there, we're basically using rail feature lines and alignments. From the rail feature lines and alignments, we're creating standard assemblies to create a track model. And then we're finally connecting that track model through BIM 360 design and then using Dynamo to be able to place rail transportation assets like electrification and signaling along the alignment. So this is yet another example of bringing together a collection of tools inside of the AEC collection to allow you to transform and digitize rail projects. So let me switch gears and talk a little bit about connected BIM. As I mentioned earlier, we're defining connected BIM as BIM plus the power of the cloud. There's things that we can do now that we were never able to do prior to the cloud. Box.com did a study that was pretty interesting, I thought. They went out and they analyzed how people are actually using different types of documents by industry in their cloud forum. And what you'll see is that in many sectors outside of AEC, there's a dense collaboration that happens around documents. In the AEC industry, we operate in a very fragmented world. So we need better tools to allow different stakeholders to get to the right information at the right time. And that's really what we've embarked on at Autodesk by moving to the cloud. So when we talk about the typical asset lifecycle, obviously we talk about the ability to plan, design, build, and operate. Autodesk BIM 360 is our cloud collaboration platform that brings together and connects all these different processes in a way that's unparalleled in the industry. It allows us to connect stakeholders, it allows us to connect processes, and ultimately what it allows us to do is create better project insights. Let me share with you a little bit about Autodesk's cloud platform. BIM 360 is the AEC cloud platform that we use to better connect planners, designers, builders, and operators. BIM 360 is built on Forge, which is the same platform as a service that is used by our design and manufacturing tools, as well as our media and entertainment tools. And that itself is built on top of Amazon Web Services. And what's unique about this is that we have the ability to not only bring together different convergent industries on the same cloud platform, but it's also the same platform that you as customers can use to build your own tools. So if you choose to build your own applications on top of Autodesk Cloud Platform, it's the same platform that we build our own tools. It's also the same platform that we use for interoperability, and even the same platform that our competitors can build applications to integrate to their tool sets. It's a game changer in the AEC industry. It's the same platform that we're using to create better connectivity between documents through the digital delivery process. For those of you that don't know, ISO 19650 is becoming the standard way that many governments are asking their projects be delivered in BIM. ISO 19650 is really a managed process for document controls through the project lifecycle. By the end of this year, BIM 360 docs will be closer and more capable in an ISO 19650 workflow. So I'm super excited in the fact that many of you that are moving to BIM mandates and many of you that are being asked to support ISO 19650 will be in a great position to use Autodesk solutions to do so towards the end of this year. Let me talk a little bit about interoperability. Autodesk is one of the primary leaders in the world of interoperability. Autodesk has always offered APIs and translation formats to get information in and information out of its platform. For the last 20 plus years, Autodesk has been actively engaged in many of the industries that you see on this chart, and many others that I haven't even listed. The reason we participate in these industry associations is because many of our customers don't just use Autodesk tools, they use other tools, and they want to operate in a hybrid and a highly interoperable environment. It's the reason why we continue to support open standards. As open standards continue to get ratified, Autodesk is one of the early adopters of many of these standards. And these are just some that are already available in our product today. It's also the reason why we've put in place interoperability agreements with our competitors such as Bentley, Leica, and Trimble. And the reason we do this is because we want to make it easy for our customers to get data into our platforms and our applications, as well as to get data out. And we'll continue to enable these types of competitive interoperability partnership agreements. Furthermore, we have special business partnerships where we believe partnering with these companies will help us transform and disrupt the infrastructure industry. 2 years ago, we announced our partnership with Esri. Esri is the leader in GIS, and there's a logical convergence happening today between GIS and BIM, and we want to be at the forefront of transforming the way that happens. We also made an investment in a company called Origo that is leading the way around cloud capital planning. And then finally, many of you have probably seen some of the exciting news about Virgin Hyperloop and the new transportation system they're building, but they're also innovating a lot of technology to transform the way linear assets are basically being designed and built. Let me talk a little bit about the convergence of BIM and GIS. What you're seeing here is a 3D scene from ArcGIS Online. And you're seeing the user click on that bridge, and then it immediately brings up BIM 360. So now you have the ability to run in this federated data environment where you can actually click inside of a 3D scene in GIS, and then you can double click and get to all the models, all the documents in a connected way. We see the barriers between GIS and BIM breaking down. And this is just one example of Autodesk and Esri working together to connect the Autodesk cloud to the Esri cloud. This has been a transformative and will be a transformative thing for capital project owners. They will now have the ability to manage their GIS data, their CAD and BIM data in federated clouds, but be able to connect them together. Let me finally talk about what we see as being the future of design as the fourth pillar in our diagram. As I said, what exists beyond connected BIM, which is what we're delivering today, is what we're calling the future of design. Many of you have heard of Industry 4.0. We believe right now where we are is making this switch from digital to machine. And I'm going to talk a little bit about some of the things that Autodesk is doing to lead the way. When we talk about the future of design, we talk about it in really two big buckets, one being traditional design and one being the ability to do things like generative solution and leverage the power of AI and machine learning. But there's certain things that we're doing in between then that will give you the ability to take advantage of the Autodesk portfolio to automate the way you deliver design. One of the things that we did last year was really move the needle in regards to design automation. We created better logical connections between Civil 3D and Dynamo Studio, so you can now use visual programming tools inside of Civil 3D. So you can see in this example, we're basically doing the automation and placement of lighting systems and guardrail along a roadway. We're also using Dynamo to do complex grading around an intersection. In this example, we're really showing the ability to automate ramp wings, which is really, it seems simple, but very much a painful process. And then finally, when I talked earlier about the investments we're making in rail, you can see that we can now completely automate the way rail assets are placed along a rail line, including the placement of rails, sleepers, catenary masks, and lines. We're completely transforming the way you're doing your existing design using visual programming tools such as Dynamo. Not only do we have the ability to use Dynamo with Civil 3D, but we also have the ability to use Dynamo with Revit. This is actually from an earlier example that I talked about, Varma 12, which was the project that Norconsult worked on. As you can see, they used Dynamo to place complex rebar inside of that 12th generator. What's really exciting is some of the new work we're doing around generative design and terrain modeling. What you're looking at here is a standard terrain model where the user has the ability to put different types of input criteria that they wish to optimize for. And the computer then is using those input criteria that are being weighted and delivering the optimum grading solution. That optimum grading solution can then be used inside of Civil 3D, it can be used inside of Revit, it can be used inside of InfraWorks. So this is a really good example of we're allowing the computer to optimize around certain conditions, regardless of whether it's a parcel of land or in this particular case, as you can see, it's a complex interchange. This is the power of using the cloud. This is some of the power that Autodesk will be delivering inside of its solutions late this year. This is also an example of some of the generative design work that was done a couple of years ago in combination or in collaboration with a company called Van Wijnen in Europe. What they wanted to do was really build a routine to optimize the way they lay out parcels using input criteria like backyard size, views, solar gain, cost, profit, variety, and program. They put this into the computer, they weighted the different options, and they ultimately let the computer optimize for the planning and layout of this subdivision. The computer basically presented them with 3 different options that were the top 3 options for them to choose from that were based on the criteria that they optimized for. When we talk about the future of design, that's what we're talking about. We're talking about allowing the computer in combination with the designer to come up with the optimum solution and the optimum outcome. Earlier, I talked about digital operations and digital twins. And what do we really mean when we talk about digital twins? Digital twins is really the digital representation of the physical, and it can be used in a multitude of different ways. But the most optimum path to get to a digital twin is by creating a digital BIM process that ultimately lands in representing a digital twin. Here's a good example of some of the work that GHD did in Sydney several years ago using InfraWorks. What they wanted to do was create a digital twin of the existing physical world to make better planning decisions. So what they did was they created an aggregated model that included GIS, different types of terrain data, different types of engineering data, different types of CAD data, aerial imagery, etc. And by creating this digital representation of the physical, it allowed them to run different types of scenarios, planning scenarios, to optimize their project. Again, this is just an example of some of the work that's happening today using products like InfraWorks, both for use in smart cities, smart infrastructure, and smart buildings. This is another example for the city of Paris. The city of Paris wants to renovate the area around the Eiffel Tower. So we worked with the city of Paris to help them build a digital representation of the city in order to explore different design opportunities. This model that you're looking at is very similar to the GHD model, where it's not just a visualization model. It's actually a model that's an aggregation of point clouds, terrain data, GIS, Revit models, civil models, SketchUp models, a multitude of different things in order to create a digital representation of the physical. What the city of Paris then did is they gave this model to their different designers, and they asked the designers to submit a proposed redesign for the Eiffel Tower. Those redesigns were then taken and published into AR/VR, and the public was allowed to then vote. The city of Paris just most recently announced the awarded winner for that project. But yes, this is just another example of using the power of creating digital twins to drive different types of decisions. In this particular case, on one of the most iconic projects in the world. But the benefits of creating that digital twin isn't just to do planning exercises like I showed. That same digital twin was then used to do a flood simulation. It allows the city to compare flood maps that were generated in some cases over 100 years ago against real-world simulations of what would happen today. So as you can see, this is just another advantage of layering over a simulation on a digital twin. But we can also take that same digital twin representation of the city of Paris and do things like mobility simulation. Every year the city of Paris shuts down certain roads along the river in order to turn them into beaches. And they want to be able to understand the implications of basically doing that. So by using Autodesk mobility simulation tools inside of InfraWorks, on top of the same digital twin model, they're able to do that. I shared with you earlier a breakdown of the Autodesk Cloud Platform. The previous examples that I showed you was our ability to create digital twins using InfraWorks, and then to run various types of analysis and simulation on that particular model. The next era of digital twins is really around publishing digital twins into the cloud. So using our Forge platform as a way to create a lightweight digital twin that's web-based, and then the ability to connect that digital twin to other types of information. Here's a short demonstration of what Norconsult did. Norconsult's the same company that I showed you that worked on Varma 12, but they wanted to transform the way they were doing digital delivery even further by using Forge. So what you're seeing here is a combined model and viewpoint that's being generated in the cloud using Forge. They're able to do section from surface, they're able to do different types of annotation, they're able to measure, and this is just some of the extensions that Norconsult has built on top of Forge to transform the way they digitally interact with their client. This is a truly inspiring way and use of Forge to transform from moving from desktop digital twins to cloud digital twins. And this is something that you too can do today using Forge. I also wanted to share with you some of the future work we're doing in research with a company called MX3D. This is a 3D printed and fully functional stainless steel bridge. Autodesk has been working on the bridge to test how we might monitor the bridge to ensure safety. We're also interested in seeing how we might collect data from the bridge to augment and monitor what is going on in a bigger ecosystem like a city. Here you can see where we place sensors to collect data from the bridge. The building information model helped determine where the sensors would go. Now watch this video of how it works. What you can see is the digital twin representation of the 3D printed bridge inside of Forge on a web app. And then you can see the employee walking across the bridge, and the bridge self-identifies where that employee is and can basically physically track that person moving across the bridge. The implication is that eventually we will use this technology to measure things like strain gauges, load cells, accelerometers, and inclinometers, information that will help cities determine the health and safety of their infrastructure. I wanted to thank you for joining me today. I hope that what I've given you is some insight into the benefits of BIM, but also where the future lies, and how you can use Autodesk BIM tools today to transform the way you're delivering these projects, but also the way you're going to transform and deliver these projects in the future. If you subscribe to Autodesk technology and you participate using our AEC collection and BIM 360, you are well on this journey. So thank you for your time today, and I wish you all well. Thanks.